So the concepts that I alluded to at the end of the last video are the concepts of doubling time and half-life. So first off, when we talk about doubling time and half-life, doubling time refers specifically to growth models, and half-life refers to decay models. So we never talk about the doubling time of a decay model or the half-life of a growth model. So these are defined as the amount of time it takes for a growth model to double in size. This is the amount of time it takes for a growth model to double in size. And typically what we would say is that if we took the amount after one doubling time, for doubling time we typically use t with a subscript 2 attached to it. Then we're going to see double whatever the initial amount was. In fact, if we make ourselves a little chart with t and a of t, going back to the same notation that we used in our first video, excuse me, after no time, we would have simply whatever the initial amount is. After one doubling time, the size of the population should have doubled. After two doubling times, it should have doubled again. So we get double the double amount. Double a double is 4 times that. And finally, after 3 doubling times, we've given it an amount of time to double again. So 4 times the initial amount would become 8 times the initial amount. Now, the corresponding quantity on the decay side of things is known as a half-life. This is the amount of time it takes for the decay model to halve in size. That is, to become half as big as it was previously. So for half-life, typically the notation that we would use is t with a subscript 1/2. This would be half of whatever the initial amount is. In fact, once again, if we make ourselves a little bit of a table, say t and a of t, then initially we'll just have whatever the initial amount is. After one half-life, t 1/2, we'll have half of the original amount. After 2 half-lives, it'll be half of the original amount. That'll be 1/4 of the initial amount, or a naught. After 3 half-lives, then we will have half of the original amount, and half of a half of a half, or 1/2 times 1/2 times 1/2 is 1/8. We'll be using these concepts to try to make predictions about the future, even if we don't necessarily know what the initial amount is.